Okay, Precalculus, here we go. Here are some notes for section 6.4. We're getting to the point where we're going to start calling this trigonometric stuff functions, like the other ones we have studied. So here's a little example. So far we've studied some functions, parent functions. I don't want to do all of them because we've done like 9 of them. But here are 3 functions that we've definitely spent time with this semester. And so I'm going to sketch the graph really quick. That one definitely goes through the point 0, 0. It goes through the point 0, 1. I'm going to make that a little bigger here just because I shrunk that so small you can't even tell. But this goes through the point 1, 1. It also goes through the point -1, -1. And the graph swooshes through the origin. Y equals 1 over x. You can't put a 0 in, so you get a vertical asymptote at x equals 0. Remember rational functions, anything that makes the denominator 0 is a vertical asymptote. And also, if the degree is larger in the bottom than the top, you get a horizontal asymptote of y equals 0. That was from the end of chapter 4. And then the 1 over x also goes through the point 1, 1 and -1, -1. But it goes through and behaves like something called a hyperbola. It's got 2 branches. And then log of x was the inverse of the exponential function. And where the exponential function had a horizontal asymptote at y equals 0, the logarithmic function has a vertical asymptote at x equals 0. And it goes through the point 1, 0. And the log of x looked like that. Now, we've done like 9 of those. The square root function, the x squared, e to the x, just a bunch of them. And here are the important characteristics that we discussed once we figured out what the graphs of the functions look like. So you get to look forward to answering these 10 things about new functions called the trigonometric functions. We described a domain. We described a range. Those are both going to be very important to us with the trigonometry. We looked at where the graph is increasing and where the graph is decreasing. Those are going to be very important to us in the study of trigonometry. We looked for the y-intercept. That's less interesting to us in trigonometry, but we'll talk about it. X-intercepts, those are pretty important for every function. We talked about where the graph is positive. That means it's above the x-axis, right? The y values are positive. That's here, that's all of this, that's all of that. We talked about where a graph is negative. That refers to where the y values are less than 0, so that's this part of the logarithmic function, and this part of the rational function, and this part of the swooshy. Then we talked about end behavior as x approaches negative infinity and as x approaches positive infinity. What happened to those graphs? I could go further. We talked about what's odd, what's even. I mean, a lot of characteristics of functions so far, even during this hybrid craziness of 2020. The next 3 parent functions we will be studying, starting immediately, are y equals the sine of x, y equals the cosine of x, and y equals the tangent of x. SOHCAHTOA coming to life. We're going to turn those things into actual functions and graph them and see what they look like. Go to page 2.